Okay, stream 1, okay, stream 2, okay. So, hello everyone, welcome back to this Codevember session. Let me just turn a little bit this. Okay, welcome back to this Codevember session number 25. In fact, yes, it's 25. And we're continuing our little experiment, our 1 month experiment around body interpretation, using Unity, using compute shaders, and stuff like that. So, what did we made yesterday? Yesterday we made a sympathetic one, which was quite a simple one, but simple in the idea, not specifically in the making. We made this simple one, some kind of grainy, sandy man, which lose over time some of this some of particles. So yeah, so basically it's a man made of particles and another particle instances which can fall every time. The video capture seems a bit odd in terms of speed. It looks like we have some variation in speed, and I think it's because the final iteration holds too many instances for my little GPU on my laptop. So the Unity run at 30 frames per second, but I've tried to export it at 60 frames per second using FFmpeg. So I think that there is a mismatch between the target frame rate and the actual frame rate, which seems to have this kind of variation in speed during the animation. But that was the idea. So what do I want to make today? I thought about another little experiment which can be really not simple in the making, but some kind of a fork like this one. So I really like the way this one is behaving. It behaves like with a little bit of elasticness, etc., etc. So because it's made with physics, so we have some kind of an attractor which going back and forth. So it was really interesting. So I think I will start with this one, in fact. So I will make a fork of this one. But what I want to make with this one is changing completely the design and maybe making something with less elasticity in the behavior, and maybe adding something like collision. So my idea was to make a man made of Daruma. I will show you what Daruma is for the one who don't know that yet. But yeah, Daruma are little figurine from Japan. It's a lucky charm. So I want to make a man full of Daruma, and I want to make this Daruma collide on themselves. So it's kind of new things that we haven't explored yet, but I think it's potential it can be made easily, especially if we have, let's say, thousands of elements. We don't need to have 10,000 of elements, but maybe 5,000 would be enough. So basically the main idea resides on the fact that you will need to loop over all the instances inside the compute shader, and we will find the distance between the two Daruma, and we will need to check if they collide. So maybe we will have to think about it a little bit. So I think I will go with this one. So this was the 24, 23, 22, 21, 20, so it's the 19. So I will start with the scene 19, in fact, and I will fork this one. So let's go back with 19. Okay, and let's fork that. So the scene is 11:25. Okay, we're good. And if I click play, here we are, our little bouncy guy. Okay. First of all, I will duplicate every script we would need in order to make our little guy. So the compute shader, of course, we would need the shader 19. I do not remember if we made a special vertex shader, but I don't think so. Yeah, we have one, so let's duplicate also. I don't think it has a specific thing inside. Let's check. No, basically it's basically the same thing. So you know what? Let's try avoid duplicates vertex shader if we don't use this one. Okay. Then maybe we would need something like that, but let's check. Okay, the controller is the 19, so duplicate the 19 also, and the controller here is the 19, so duplicate the 19 also. Okay. Mm -hmm. 25. Okay. Then get the GPU mesh controller, not the meta file, but the file, which is here. So 25. I would take the compute shader because we would work specifically on this one, and also I need to open in the shaders the 21 material, which is this one. We have a color bump map, a metallic, a ruggedness, a cube. Okay, this one seems to be quite simple, so I think it could work. Okay. Well, now that we have this one, we can change a lot of things here. So I thought I would duplicate the 19, but no. So let's duplicate the 19 material. Okay. And change that by using the custom 25. Okay. Yeah, that's why we use the RAM, but we have the albedo emission. Okay. So as always, we would need to change the controller. So this is removed, and then I would take this and I will keep this just to check. So yeah, we have 500 elements, so I think it's enough for this experiment. We had a sphere on this one, so it was the sphere from Cinema 4D, you know, the icosphere. I'm trying to reproduce really the same thing right now, so but with basics values, basics values. So it's 11:25, so this is this one, and we need 11:25. Okay, and we would need a ramp, which was, let's try to use the same ramp right now, which is the 3, I think. Okay, so the sphere would be too big, I think. Yeah, so now the sphere is really too big, but that's the idea. We have the basic system, so that's okay. We have the basic system. So what's the diorama? Let me show you. A diorama is something kind of a lucky charm. It's a lucky charm. It's a little figurine which come from Japan. I invite you to discover what is it and how it's what's the story behind the Daruma. But it's really interesting, and it's come from the basic story behind this. It's based on the story of a monk which wanted to pass a lot of year meditating, and he has fallen asleep, and when you awake he's decide to cut his some part of his eyes to be sure the eyes will be wide open, and it's a symbol of I think I have the word in French, so I think it would be something like of course I'm writing on the wrong screen. Yeah, it's the same. It's the same. It's the same name, in fact. So it's a symbol of perseverance, and the Japanese has made, based on the story of this monk, a little doll, which is a lucky charm, and we can find various color of this doll, and basically each doll can be a symbol of change for every domain. And what you need to do with this doll is, of course, change is not something you will get for nothing, so you will need to be to have a singleness, to be perseverant about what you want to achieve. So you will fix a goal, you will paint an eye of this doll which has no eye at first. You will paint an eye, then over the time you will try to do your best to achieve your goal, and when your goal is achieved you will paint the other eye, and then you will burn the doll as a symbol of achieving your goal. I think the basic story is here, and I'm making some mistake, but my wife told me this story when we were going to Japan, as she was making a lot of research about that, and in fact we buy some, and it's really beautiful doll made of papers. So I wanted to work with that. I find it really beautiful, and I wanted to try something like that. So let's try to change a little bit the shader. So we need to fix the normal, of course. My voice is going. Okay. First of all, I will focus on the shader in order to change that as a texture, because we have a texture, so it will be white for metalness, gray for, well, let's say gray for roughness. Okay, so now metallic is a sampler, so we have the ramp. I think the ramp is never used, or is it? No, this ramp is never used. We have the albedo ramp. Okay, we have the ramp right here. I don't remember if we use this ramp right, but doesn't seem so, so let's get rid of that. So this is the rough, so let's say a metal, and we will use the metallic texture, so it would be a metal normal, a metal.r. Smoothness, okay, so that's right. And you know what, as we are using something and I don't want to override that, I will save this vertex shader, but the main idea is, in order to debug everything, is to say that the O dot color is at first equal to a float for of 1111. Okay. O dot color. Let's change that by 25. So now we could see, and let's say RGB multiply by in.color.rgb and comment this part. So we would see the texture of this little diorama. Okay, so here it is. First of all, I need to say that I haven't made this Daruma doll, in fact. So it's not mine, my 3D model. I buy this one on CG Trader, so let me show you the reference. So CG Trader, I try to I tried to 3D scan one, but I didn't add enough time to make the proper photo shoot, and also because 3D scan is pretty new to me and I'm trying to learn it, so I'm still at the beginning to understand what kind of photo can be good and which one can be not good enough. So let's say we are a human, and I will show you. Okay, so where's my model? You have no problem, no, not my model here, but I want to have my purchase. So here it is. So this is the model I bought on CG Trader. As you could see, it's really interesting. It's really simple. In fact, you have various subdiv available. I've used the simple one, not the second subdiv, and it has a nice texture, so it was easy for me to edit the texture. So yeah, this is what I bought, and of course I will not be able to share this in the Git because it's a licensed one, but maybe I will try when I will simplify everything for the Git to let's say make something non-3D and try to retrieve a simple one. Okay, and also for this Daruma, because I thought it would be interesting, I've also tried to, let's disable the post-process just to see the lighting, so you see it's really beautiful. I've also create various texture for this one, because each color in the Daruma, in the Japanese culture about the Daruma, each color has a meaning. Okay, so basically I think so. Yes, this is it. The red, as we could see here, is the main one. You can see it everywhere in Japan. It's for chance, but we have a lot of different color. Black and gold is for spirit protection, against spirit protection. Okay, so it's really also beautiful. You have also a blue one, which seek professional wellness. You have a gold one, and my gold is not really beautiful, it's more like a yellow one, but it means to be a gold one at first, but I think I will need to recheck, especially the roughness for the metalness for this one. But the gold one is for wealth, of course. The green is for health and shapes, really body shapes. Pink is for love, of course, and love is important, you would know that. Violet is for health and personal development. So it's another kind of else. And white is for harmony, and at last we would add a yellow one, a little yellow, which is for security. So I would like to have different kind of daruma, and changing the texture might be a little bit not complicated, but it might require something. I'm not sure about the size of the texture. I think it's it's 200. It's really a well-defined texture. 2088 by 2088. So I think we would try to create some kind of an atlas. So let's start with the main one, which is basically the chance one. So let's start with this one. Okay. So first of all, let's bind our little daruma here, which is a simple one. As you can see, we only have 2109 vertices, so it's really small, for instance. And let's try that. Oh, of course. I haven't put it in the right in the right element. So yeah, this is here. So now we have all of our little daruma, and they have a basic size here. Disable the environment. My environment is not really beautiful. I think when we would work on the art direction, when I would retake everything. So yeah, this is my little daruma. You know what? Let's try to work on that one. I don't remember if they are rotating on themselves, but I don't think so. We have some curl noise, but I don't think they are rotating on themselves. So if we try to retrieve what we got here, we could have small daruma and bigger one. And I think this would be also a great idea to play with size, because in Japan you can find small daruma and big ones. So it's really interesting, and it's more interesting if we can collide on themselves. Okay. So in order to get to that, we will need various things. So this is the shader. So let's try to read what we make lately. So this we get every element. So transformatic rotation, origin scale matrix, and scale matrix. We also have the original position, the velocity and the acceleration, and the position, which is basically on the matrix. So this is the actual position. We had also an index, which is basically rereading basically the property at ID here. So in order to loop over the property, we need to loop over this little array. We have some times here, but I don't think we use this time. I'm not sure, but I think we could get rid of this. Or this part might be, I'm not sure we've used time, so I think we can simply say that. And I think we had something elsewhere where we used the time, so let's check. We use the time here. Yeah, and you know what? We will keep this one. It could be interesting because it's a time per. It's a time plus an offset, but I would use the random data, which is basically on the opposite at the position W. So oppose.w, so I don't need to make another random. Okay, so if we can get rid of this part, let's get rid of this part. Then what we had everything like that, and we had a velocity. Okay, remember we need to when we made this one, we haven't scaled down. We needed to simplify everything, but we haven't scaled down the velocity. But maybe we're taking what we've made. Let's try that. Redefinition of desire. Of course, I redefine desire. Okay, that's what I thought. Usually it didn't work. So does it come from that or that? Yeah. Okay. And because of that, what I'm trying to know is why this is simply okay. Okay. So of course we need to change the speed, the min and max speed, which is here. The min speed is not used, so now we only use the max speed. Okay, so let's say 4. Hey, merci Julien. Okay, now we have a max speed of 1. A max speed of 4, sorry. So max speed is okay. Curl scale. Okay, and now I think I would need to change this, the min and max force. So let's say we want a min force of 1 and a max force of 1. Okay, we are reaching a point where it starts going interesting. And of course I think this is more something like that. Whoa, 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 whoa. know what, let's simply get this, but say that this is a steer force, steer max force, which is basically that. Min speed, max speed, R&D off, R&D off, RAM size, the RAM size is okay. So where did we make a mistake? I haven't declared this. Okay. And the min max force, we need also to change it. Okay, let's disable this one. So now we have a little system here. Okay, so where does it have this little guy here? If I do that, it would be, of course, that. If I multiply by that, we start seeing something here. We're trying to understand that. The target is this one, so sure. But if I'm going here, it's not as smooth as we had. So let's try to reread what we've made here. So it was 01, 061, 06, 066, but we haven't normalized this. So it might come from the normalized value, I think. Here, if we disable the max speed here, might be the thing. You know what? Let's retake all this little guy here and reuse them directly, just to retrieve our little system. Okay. So now we could change a little bit this part. So for example, if we basically setting a val here, so that's I think we will need something different here. I want to make things to be less elastic. More like that, yeah. Maybe something like that. Okay. Okay, so let's say something more like something like that. Let's try that. Okay, so we will need to change the curve. So we had that, but maybe changing a little bit that. Woohoo! More curl power! Okay, more like that. Too many curl. If if we increase the curl, we might reduce the curl speed. Yeah, it's more what I had in mind in terms of little jiggy elements. Okay, and the curl is based on this plus the time, and let's add the oppose.w, which is the little random value, so we could have a little bit something a little bit different than the things we had at first. And we disable the rotation, but I think I will try to re-enable it to check it. And let's try to scale this a little bit. So yeah, and you know what, maybe in terms of rotation we could use the curl as an axis. I think it would break everything, but it look like little guy seems to be a little bit odd, but oh yeah, I have a changing angle, not the axis, so it's more like that. Let's try to pause that and try to see the orientation. Okay, so let's try to add the axis to that. And now we have something really different, so that's normal. But you know what, in fact the vel should, the axis should take part of the vel, so I'm not sure about this one. Okay. Or maybe I will need to scale down these two vectors to slow down a little bit the rotation by, let's say, 25. No, we didn't change anything on that one. Maybe it's directly this one that I need to scale down, but I'm really not sure. Yeah, I was not sure, and that was why. In fact, I think I might have a problem here. I've taken the absolute value of the cosine, but the half cosine will return something like so let's say pi between minus pi and 2. So let's define pi. So it could be more something like plus 505 and we could add a random vector to this rotation by simply taking the oppose the w multiplied by pi, for example. Oh, made a mistake somewhere. Basically, I think I've made a mistake here by taking by not writing pi correctly. It's kind of speed, but why do I this? Yeah, it's normal to have this kind of rotation, in fact. Okay, so this seems okay to me. Need to start the collision. So where do we want to check that? Do we need to check before updating or after? Could check after that, but we need various things. First of all, I think we would need the number of instances, so it might be a necessity. You know what, let's change this buffer here. So in the compute, I would say compute.set float, which will be max instances, and this is max instances. Okay, so now I can loop over each of one. So let's say uniform float max max instances. So we have a UE int 3 here, so let's try that, and we want to find that. So it might be something here. Okay, so for int equal 0, so I need to loop over each instance. Okay, so int strictly inferior to the max instance cast as a hint value and I++. Let's create a u hint 3 u hint next, and this would be, no, I don't need that. So if basically I is strictly different of id.x, okay, so if we're not on the instance we want to read, we will try to do to look over that. Okay, so now if I is strictly different than that, okay, so now we can basically take this. So I will need various things. So first of all, I will need that little guy here. Okay, I don't need the rotation, I don't need the scale, I don't need the... Do I need the oppose? I think so, because I will need to retake. Yes, I will need to retake the... I need the oppose because I need to take care of the scale for each one. So I need the oppose. I don't need the... Also, I'll need the vel, the vel for it, and the position and the index. I don't need. I could use this index, so let's try to retrieve it, and we will name this as neighbor. So neighbor Tiamat, neighbor vel, neighbor position, neighbor index, and this would be simply that, and that, and instead of id.x, it would be simply high. So this is high. Okay, so this is my neighbor. Okay, so I also need to know the size of the neighbor. So basically what I want to do, so let me explain the basics here. So we have two little daruma, and as you can notice, it's not a complex geometry. And what I was thinking is, instead of checking if the two daruma is really collide, because we have a lot of daruma, it may be simpler to simply check, to imagine a spherical collider which can embed the daruma. Okay, so it's a sphere where a virtual sphere, in which one we can have the daruma. So basically we're taking the position, taking the size. So maybe, I don't know, the y, so the y seems to be the bigger size, so I will take the y as the radius of my sphere. So I will take the position of the elements, the position of the neighbor, and check if our two are colliding. So if that's the same position minus the sphere, so the two position minus half of the radius of each size, then okay, it's a collision. Then if a collision, we invert the velocity, and I think this would be enough, and I think we would need to update the position after that. So we need to retrieve the size, and the size, we know that because the size is that little guy here. So I could basically take the same things as here. Okay, so yeah, we took the norm y of the neighbors because we need to know to retrieve its own size. So this is the ney norm y. We have also a ney UV ramp, so it's take care of this. Equal okay, and then the ney ramp size is basically equal to the body ramp, and we load at the proper value. Okay, then the ney size would be, of course, we will use the same thing, the mean scale plus the ney ramp size. So now we have everything. So let's check the distance between the two of them. So basically the distance between the two of them is is the vector going from for our position to the target. So target minus position. So we need the length of this vector. This is the distance. Okay, so float distance will be equal to, I think you would need for me to add a little, okay, in order to align everything. Okay, so this distance is basically the length of target minus position. So the target is the neighbors minus the actual position of our little guy here. So this is it. So this is the length, and if this length, so So if this distance is less or equal than the size of our element, the half of the size of our diorama and half of the size of the neighbor diorama, then which means we are colliding. So we could take size.y multiplied by 0.5 plus naive size dot y multiplied by 0.5, and if it's that, I would take the true velocity and say go back. So if it's right, then of course navel multiply by -1 and vel is multiplied by -1. And I thought it might be interesting to change that. So let's try it with this part. I'm really not sure about what I'm doing here because I never try to loop over the instance inside a compute shader. So I might be ending with a lot of error and maybe it will not working anymore. The good thing is the shader is compiling, so that's okay. And I think we are always colliding and we cannot avoid anything. So let's try with less element. It seems we are always on some collision. We could also try what that. Oh, nothing. Okay. We could try the distance in fact instead of this. So we could try simply the distance between our two elements. Distance identifier represent, oh yeah, I call it that way. So okay. If this distance is less than the two sides divided by that, it would be correct. I think it would be correct. If we reach a point of error, let's train with 10. We would clearly see with 10 elements if we reach a point of error. As you could see, look like we are basically it seems it's trying to do something, but high, so that is okay. Look like this one is really on. Not sure about what's happening here. Some are really following the foot, so for some it looks like it's okay. For other, it might be quite complicated. Let's try to increment a little bit our guy here. Let's reuse the same thing that we have here, just to be sure. Let's use a constant to check if we can have some kind of a collision. Let's avoid the curl, let's use only the steering behavior. Okay. So yeah, and I was thinking about updating everything after that. Okay, this is really not something that I had in mind. I think it's maybe more interesting to add the forces than update. Yeah, then update the velocity. But no, as you could see, it's clearly always colliding. I'm not sure about this force. This is less than plus that. This seems to be okay to me. So why do we have this inversion? Look like everything is always on the edge. But if this is different than this, so it looks like we are taking the actual. Oh. If we're taking the actual ID, it would be every element we go. Yeah, they are clearly trying to go back to their position, but it seems really odd. Okay. Let me check. Maybe I could create a separation force. Instead of a collision, it would be something like more a separation force, you know, like a flocking system. You go back to the nature of code in order to check. So we use the seek. That is okay. We use the separation and seek. Yeah, I think it's more something like that we wanted to achieve. A seek, but a separation. So let's look into it. So we have something like apply behavior. That's not a problem. And we have an update and a display. Okay, so let's look into it. What do we have here? Okay. So this seems okay for me. So apply behavior, we have separate force and the seek force. So the seek is what we have. So and we have two applied force, and applied force we know what it means. Take the force and it's adding to the velocity. So we add the separation and we add the seek. That's okay. Let's look at the seek. The seek force is that. So seek is basically target minus position. So this is the desired vector. It was scaled to a max speed. In fact, he has changed the max speed to the max force, and I think it's not kind of problem, it's a misconception in our name, so not a problem. But okay. And then we have a steering behavior, which is basically the target minus the velocity. So okay, and this is also this has the limit, so we don't need to go over certain things. So here we have simply scale it also. So this is the steer, so our steer is correct. And now we need to separate. So the separate is basically, so the desired separation, we know that. So this is that. So float desired sep is basically equal to our size dot y multiplied by 0.5 plus the naive size dot y multiplied by 0.5. This is the desired separation. Then we would have float 3 sum, and we need to count the sum of every vector. Okay, why not? So let's say float 3 0 0 0. Oh, I say 3 to 3. Float 3. My float 3 0 0 0. Int count equals 0. Okay, and then we need to say, so we clearly on each element here, so the sum and the vector is need to be outside. Okay, and now we have here, we have that, so it's not a problem. Now that we are here, we need to take the distance between these two elements. So float dist is basically equal to the distance between our position and the naive position. Okay, so naive position, this is basically that. Okay, so it's okay to me also. Oh, and I think we didn't take this correct scale here, so that might be incorrect. And if this distance is of course superior to 0, we cannot have a distance which is less than 0, and we might also need to maybe increase a little bit in case of something is really on 0, so we'll need to let him leave, so that's why. And sorry, and if the distance is strictly less than our desired separation, so basically we are colliding here, so float 3 difference between the two vector would be simply the vector which is going to the position to the other position, so the other position to the position. So I need the vector which go from our little guy here to the element which is colliding with him. So the target is my actual position to the neighbor. So this is the position minus the naive position. Then this is normalized, but I think we would have something basically breaking here, because when we use the normalization here, we have some kind of break inside our computer. I don't know why, but you know what, let's try that. And we will divide this by the distance. Okay, then we would take the sum vector and we would simply add the difference, and we would say that because we have a collision, the count will be plus plus. Okay, then after this, if the count is superior than 0, so if we have some collision, then the sum need to be divided by the count in order to have an average vector. Again, the sum is normalized, but I think this would break, so let's say we normalize the sum. Then the sum is basically multiplied by the max speed. So this is our little guy here. He used what? He used the max speed. Like in the SIG we used the max speed, so it was something like that. So let's say float min max fourth. This is this one. And float min max speed is this one. Okay. Okay, so I'm putting this into variables in order to reuse them. So I need to say this. So this is okay. Then sum will be equal to we say sum will be equal to like the sum minus the actual velocity, and we will need to limit this little guy. So sum would be, and of course I'm not sure again it would work, but you know what, let's try that again. And the sum would be the length of himself, so if it's go over the min max speed, so it will be normalized to that. And this is basically, so this is the SIG behavior, this is the curl, and this one would be the separation. Okay. So now after that we would simply try to add the sum to our acceleration. So acceleration would be plus equal the sum of our separation. So we could rename the sum after that. And also he made the separation bigger than the 6, so by simply multiplying it. So you know what, let's try this. I think we would have strictly nothing. Unexpected token float, yeah, because I forgot this. I think we would end up with nothing as the last time. Yeah. So here we are. Our little guy are clearly out of the edge. Okay. So let's do not multiply this and say that. And as you could see, it's clearly not what we wanted. So you know what, let's try to not normalize the little guy here. I'm clearly quite surprised about this. Look like everything is always on separation. So yeah, look really strange the way it's behaved. The distance would be something like that, but because we have the scale matrix, I think the scale is really mess up with everything. So if we simply try to add things like that Does we always mess up with that or not? As you could see, we have some kind of bouncing. So maybe we could simply reduce this by 0.5. I think the fact that we're using, if I'm true, the fact that we are using a scale matrix might be our problem. Something also strange is that it's behave like, we don't have a curve, but it behave like clearly a diagonal. So it's quite strange. It was like we didn't have the same component, but it's a float 3, so it might be the same. First of all, let's rename this as sep for separation. Oh, I know what. No, I don't know what. Yeah, I know why we have this behavior as a simple diagonal. It's because the diff is not a float 3. I've took only the first component, so that's why. Undecline identifier sum, of course, undecline identifier sum. So yeah, because it was a float, not a float 3, we simply update all the components with the same value. So we've made also another mistake somewhere. Where is it? Here we are. Now it's sep. And now they try to basically avoid themselves. So now we're okay. We have the steer and we have the separation. So we could force the separation instead of the steer if we want. So clearly they are going to be we can force this, and we are nearly like a flocking system in fact, because and if we want to reduce a little bit the velocity at the end, we could scale up the vel because it seems to be really speed. So now it seems to be a little bit more small and more interesting. So of course 0.1 is really too much, but something like that might be more interesting. And we still have some elements which seems to be colliding. So let's increase the separation to be sure. And I think we would need to increase this little guy here to avoid them to be it may be the max vel which is too much. What's happened if we normalize it? I think 1 is really big. So normalization is really big, and if we say something like that, float max vel would be something like, I don't know, 0.1. So if it's that, we will try something like that. Not sure, but I'm trying to rescale it a little bit to the end. And 0.1 is really a big velocity. Can reduce at the end, but not sure. Okay. So yeah. I think we have two ways to intervene in this little system. Would be that and that. Okay, this is better. Clearly it's some kind of a problem and not because I am starting to learn more about compute shader and try to understand more what's happening here. And the fact is, maybe the thing is we are dealing with really scaled vector, but in Unity we need to, in compute shader we need to think between 0 and 1, so usually you have this scale problem. But as you could see now, we are seeing the Daruma moving, and maybe we could simply increase a little bit the mean force here, as we use also here, so we can maybe reactivate that and deactivate this 2, which is basically the old one, and see how it's behaving. Okay, so clearly the Daruma is really too speed, but again, the angle is based on that, and maybe that would need to be clearly really small. I don't know, I'm not sure about how to. No, this is clearly the same thing. And we clearly haven't changed too much things, so let's try to increase our speed a little bit to change the behavior of something less elastic, as I said earlier, something which be more fitting the position of our little guy. So something like that, for example, might be interesting. So maybe we want to avoid the rotation for now to see the Daruma. Okay. I want to try to retrieve a little bit by simply changing the speed, the scale and everything. I want to try to retrieve a more humanoid shape with less elasticity and less retorts on the last foot, you know. So maybe something like that. Whoa. Too much. Too much, but let's try something like this to this. Maybe a little bit too jiggy. Okay, so let's get rid of the body and try to change some of this cute element here. So this is our little Daruma guy. Let's try to change some of the size here a little bit, but we are keep retrieving some of the elements. So what happens if I change basically the model? No, I didn't choose this, so not a problem. Okay, let's say now we want 100 of elements. Yeah, 100 might be too much, but it also it is too much, but it also might be interesting. Let's put the same speed for everyone. This could be really interesting. Min-max speed would be 0.9, for example. Okay, let's keep them for a moment. Let's get rid of this. Oops, this one, and let's say something like 0.9. Okay, 0.9 and see the behavior. Wow. Too much. 0.75. So what I'm doing, I'm trying to, this is kind of an experiment where every day I'm trying to make some kind of a body interpretation on Unity. So that's why I'm making. And here, this one for tonight is basically a man made of Daruma. But for me the speed is too much. So I'm trying to find the proper behavior. Yeah, something like that. It is more smooth like I thought, and I would need to change a little bit. That's why. So the distance, then if I put the desired separation here, which is basically what I don't want to put, I would have something fully explode. Okay. So maybe the proper computation is 1 divided by this value in order to retrieve a correct value. Clearly not. But we have some kind of very interesting system. So 1 divided by that, by size of this, I'm clearly not understanding why the size would be too much. Size.y look like the desired separation is clearly not, but size is this one, min plus the ramp multiplied by that, which is here. But it's a scale, in fact. So that's why it's a scale. Yeah, okay, I'm now understanding what's happening. Okay, so for the size I'm understanding what's happening. So basically the scale matrix is a multiplier. Okay, it's clearly not a proper value, a static, a constant value. It's a multiplier. So basically you take the vertex position. So remember the vertex position for a mesh, like something like on this mug, for example. Oh, I have some tea here. So yeah, if I'm taking the tea on this mug, and let's say the border of this mug and every element. So let's divide this mug into a grid, and in this grid, so for example, let me draw on my mug. I will wash it later. So a mesh is basically something like that. Okay, it's a grid of vertices. Okay, so basically this is my mesh. Okay, this is for, okay, so this is my mesh, so this is a grid, and this point is a vector, and the vector is described by basically taking the position in 3D space relative to the origin, and the origin in our case might be the pivot point of our mesh, which can be, for example, for this mug, for example, if I'm manipulating like that, in the center of the mug. So this is basically a vector going from the center to this vector. So it has a size, it has a length, and the rotation matrix, the scale matrix, sorry, is basically a scale for that one. So I'm taking this vector and multiplying by this matrix, so I will scale down this. So if I'm taking the size, I'm taking the value which is bigger, maybe bigger than our actual vector. Okay, so that's why it's not the proper value. The main idea for getting a proper value might be to compute some kind of bounding box for our mesh, which for our meshes. So we can retrieve, in fact, the bounding box of our mesh, then multiplying by the scale. But I don't want to do that, and I think because it's nearly 22 20 more than 22.5 p.m. So I don't want to put that. So I will keep working with some constant value, so something like 0, 0, 25, which is not the bounding box, of course, but it's kind of a way to retrieve, as you know, that some kind of bouncing behavior directly inside our little guy. So some of the elements seems to be colliding again, so it's not perfect, so I will need to tweak a little bit this value, maybe 30, 35, 30. Let's try that. So 35 might be too big, so 35, 20, 30, 25. So 0, 3, 25 might be maybe a good, yeah, I think it might be a good guess, because we know I have some kind of little bouncing behavior. So let's try that. Okay. Maybe if the main problem again, if I want, because it's, of course I'm using a constant here, but if I want to change this, for example, and I put my diorama with different size, I cannot take the size in account, so it's clearly not correct. So you know what, let's try to see if we can get the bounding box of the mesh. So we have this, which might be interesting. Okay, so we can this is the align bounding box of the mesh in a local space, which is not affected by the transform. Not that random bound property similar return bound in wall space. So we want the local space, so this is correct. So the box seems to be the size.x, which is the width. The width, the size.y might be the where is the bounds? It's bound this mesh.bounds. So I think mesh.bounds it basically return a vector 3 or a vector 2, but it's meant to be a vector 3 inside the bounds. We have this little guy here, so bound. Okay, so we have mesh.bound, which can give us this. It's return a bounds, and in the bounds it's a line axis box. And we have the center, and we have the min, the max. So this is the maximal point. So we have to center plus extent, the minimal point of the box, the size always twice as large as the extents. Okay, yes, the size is basically a vector for width, height, and depth. And we could use, in fact, the max value, which is the maximal point of the vent. So this is equal to center plus extents. Okay, so I think we want to have the extents. Maybe this can be interesting because it would give us the maximum distance on the box, which I think we want to retrieve that. So let's try this part. Okay. So we need to get the mesh, of course. So it seems to be something that we would bind to our shadow. So let's create a new uniform, which is a float, and this will be max distance. And no, it will not bound as a uniform because it needs to be per instance, because it no it can be sorry, I'm clearly making a mistake. It's not per instance uniform because we're using the same model, so this one can be clearly for everyone, and the instance is basically the size, which is the multiplier of our bounds. So max size. Okay, so yeah, go back here. Where do we have our mesh? I think the mesh is somewhere here. So we have the mesh here. Okay, and the mesh, oopla, the mesh is basically used here. And tac. Do we use the mesh? Yeah, we use the mesh here, and I think we would need to take something like that. Okay, so we need to find the bounds of the mesh. So let's say bound is equal to mesh dot bounds, and now the max, yes, that. So float max distance would be equal to bounds dot max. Okay, and after that we could in fact bind this to our shader. So compute dot set float, then max distance is equal to max distance. So if I'm correct, this could bind our max size here, and now the max size is basically the center plus the extent, so this is basically the max distance in the bound, which is I think to be the maximal point of the box. This is the way center plus extend, and extend is half of the size, so extend is nearly a border. So it might be correct if I'm saying something like multiply by my size and multiply by max size, and now I can use this desired here. I might be correct, but I'm not sure. If not, I think I will go to another thing. So implicit what? Where did I make a mistake? Implicit convert type vector3 to float. Oh yeah, it's a vector3. So was m min m size yeah, it's a maximum point. So I think we will not do that. We would use something like the extends. So max distance would be extends y. I want to put, I know my mesh, so I know that the maximum distance will be the height and not the depth, and even not the width. So I would put this value instead. So I know my Daruma fit inside the sphere of that. Okay. Whoa. No, every Daruma seems to be clearly fixed. Why? When we put something like 003, okay, and if we put now the desired distance, it seems to be fixed, like it never collide, but it has some kind of a collision. So maybe I could say something like that. Did I put this inside a proper value? Max distance. Oh yeah, I put something named max size and to max distance, and now I said that it was 0. So yeah, that was my problem. And in order to keep everything, we will name that max size to be sure. So I will not have a problem binding values. Need to work on my English. Okay, go back here. Let's try, and I think I've made a mistake. I've let a mistake somewhere, so but I'm not sure about this, because I think that was a mistake here, but look like the behavior was also a mistake. So let's try that. So yeah, as you can see, we seem to have the same kind of problem even with this extend. Zero 5, 0.25, for example. Okay. So why do we have this problem here? we have the size. Yeah, I think we need to of course multiply the size by 2. Not sure about that, but by 2 by divided by 2 in order to get only half of the size in terms of a radius. Yeah, I think this is more correct now. Look like something more like avoiding collision, so look like more interesting now. What's about, oh yeah, as you can see, it seems we keep consistency inside this, so it seems to be okay. And does it work also if we put something like 0.25? Yeah, now you see that we are keeping, okay, we're keeping the size. So this is the correct way to manage avoidance directly into our compute shader. Okay, time to take care of our little shading part, because we have our guy and we would reactivate, I think, the element. Do we want to I'm thinking about the way to do that. As you can see, the body is a little bit the element seems to be a little bit retarded as some how can I say that, slower than the body. The elements are slower than the body, so some elements arrive with some delay. And that might come from the force, of course. And if I don't save my file, I will not update it, so let's try that. So I think this is more correct. Okay. So how can we distribute these little things here? The fact is we have various color. I've shown you the various color of the diorama. Okay, but I cannot change. Basically, I cannot. In CPU, you can change the value of the texture, but here I cannot change this one. So, how can we do that? There might be a way, but I think there might be a way, but I'm not sure about this. There are different ways, in fact. The first way would be to have some kind of a, an atlas. And this could really work. In fact, the atlas might work because I would not need to make some computation for the color and anything. So let's try that. Let's try an atlas. Let's try a 1D atlas and not a 2D atlas. So what's an atlas? What's a texture atlas? Basically, a texture atlas is a way to avoid latency. I think it's a way to explain that might be like that. A way to avoid latency when you load a texture by simply take all your elements inside one big texture. So that's why we called it an atlas. It might be faster to load because you might have experienced that with processing, for example, or with other files. So if you want to put a folder from your working drive to another drive. For example, Unity, for example, a processing full of library, etc., etc. It can take more times to copy and load each small file than copy a big file and load it. So that's a way to have everything inside one big texture. Also, an atlas is really useful. I've used them. I use them a lot in the studio for various things. So, for example, if I want to, for a project, I needed to animate a bird using a movie. Okay, so I had a movie of a bird, and I needed to this is a little movie animated, and I needed to use a mask. So I had the bird and I had the mask, but the problem was, if I take basically a movie texture and another movie texture all separate, and put them in a shader and try to use the mask inside the albedo, because we have two video player, we might end up with some delay or decalage, with offset decalage. What a French! Some offset in the frame, so the albedo might be on the frame, for example, 30, and the mask on the frame 25, because your player are each playing on a specific thread which are not synchronized, etc., etc. So a way to synchronize everything would be to put your movie inside one on the top of the texture, and the other movie, so the mask, in the bottom of the texture. So for that we'll only play one video, and then in the shader you have this some kind of atlas when you know that the texture is on the upper left and the mask is on the upper down, and you need to remap the UV to just taking the right one. Another thing as texture atlas is also the sprite animation, where you can find all the animation elements on the same texture, so it will be easier to load. You will have less file, and you can basically swap in the UV in order to change the animation or change the texture. For example, the face of the Doom guy in the old NES version, every face is in one texture, so you only need to change the way you which face you want to display by simply change the UV without any loading or binding any new texture into the memory. So it's really interesting because your memory will have only one texture and you will have all the information available for you. So that's for the atlas, and now let's create our own atlas. So first of all, I think I would need to take all my little Daruma file, and this is, let's put the first one here, and let's take the blue one, and then we have the gold, pink, red, violet, white, yellow. So I think they're all of them. Okay, so they're all the Daruma. Of course, the texture is really too big. It's a 4K texture, so I think we can simply reset everything to 512 might be enough because our Daruma are really small, so let's try that. We will lose a lot of information, but as little texture it might be enough. And now the idea would be simply to go here and try to, whoops, I think I will need to snap, but where is my snap? Yeah, I have the snap activated. Okay, that's why. This was the yellow. Oh, this is a selection. The automatic selection is a mess. My. I really don't like that part. Okay, let's create a big file here. So I could simply put all my diorama. Okay, so this is yellow, so now I can put this, and now this one, this one, this one, this one, and this one. Okay, so this could be our little texture for our diorama. So let's save this as the diorama atlas, and it would be a PSD because it's handled quite well the Photoshop file. So let's keep that. Okay, so this is it. Where is my diorama atlas? It's here. And now I can put my diorama atlas directly here. So if I now click play, I will have all the diorama displaying on our little guy. So this is okay. And now let's go in our compute shader. Remember, in the vertex we put the oppose so we can get the random value. So hey, might be interesting. So okay, basically we need to remap the UV. So how many atlas do we have? The main ID. So the UV is going from 0 to 1. So if I want to only go to 0 to specific part, I will need, each time I need to go to a part, offset a little bit. So I need to know which offset I want to go. And I need to rescale from 0 to 1 to 0 to the first column. So for that, it's really simple. I just need to compute to know the number of diorama I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 dioramas. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically, which I will call my offset. Okay, this is float offset. This would be 1 divided by 9. Okay, now I have my, I would of course say that my divider is 9, so it would be better because I will use it again. And in order to remap the UV, I only need to remap the X because I didn't make a grid as an atlas. I only made a 1D atlas. So I would say something like float to UV would be equal to basically a float to of in.uv underscore main text dot x divided by the divisor. So by the divider, I forgot a D in my name. Okay, and then I would say also, of course, that the UV in y-axis is the same. So this is my UV. So if I use my ramp here, so I will name this my atlas and not the ramp, and I will simply say something like, let's save this for a moment because maybe we will use it, but I don't think so. So it's text 2D of the main text, of course, because I would domain the main text, but with the UV I would, if everything is correct, end up with my black diorama only. And if I end up with a black diorama, I will need now to define a rule to have some offset. And this is clearly not, because I've created the atlas but I didn't put it in the albedo, so that's why. So now we have all our little black daruma. So it's kind of interesting. We have this little guy here, full of darumas. So now I can create some offsets. Okay, I can move a little bit. So I need to move on the UV. So for that, we need to offset a little bit, and for that we will use. So we will update uv.x, of course, and we're basically adding an offset, and the offset will be defined by the random value we have per instance, for example, which is in.oppose.w, which is a random value, multiplied by the offset. Okay, and let me check, but if I make something like that, the main problem would be I would have random offset. Okay, so it might be 02, 04, 05, etc, etc. So I think I would need to multiply the divider by that, multiply the random value by the divider, and I will only take the floor parts, so it will be an int number, and then it will be multiplied by the offset. So by multiplying this by the divider, I would get a number between 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, of course, if it's 1, then multiply by the offset, I will get my little offset. I think so. Maybe I would need to be a divider -1, because if I get 9, I don't have to have. Okay, and it's look like something correct to me, so let's look into it. We have some white one, which is here. The white one is the last one, and we have the black, and then we have everything. So it's more like a Murakami body. So it's kind of interesting. We could also use another value than this one, something like a noise, for example. It would be also interesting. It would be less random, so why not? We could also try to change. So maybe we want only to go from 0, 1, 2, for example. So if I change the divider, I might the divider here, of course. Okay, so if I change this, I might only taking the 3 first daruma and not the last one, so I will have the black, the yellow, and the blue only. So black and yellow, as you could see. So this could be something like that. So you could have different kinds of you can remap, in fact, your color scheme if you want. But I think I would want really to go with some kind of full daruma boy. So let's try a little bit to work on the daruma, because for me it's really it has too much color into it. Okay, not too much color, but how can I say that? I think we need to change this. That's why. Okay. So for example, let's try to change that by saying something like I don't know, let's put a little daruma here, something like that, so we could see it. Let's try to scale it so we could enjoy it, and we want to put some material into it. So of course now it's less defined, so this is normal, not a problem. So this is our little Daruma. Okay. Let's try to change something like maybe we can use the alpha test because we don't have this, so I will use the alpha test in the divider for a moment. Because some of it is correct, some of them is not, so let's try that. So 0 is black. 1, 2, 3. That's strange. It doesn't. Oh no, it doesn't change because I didn't say something like that. Okay, let's try to change that. It would be something like floor alpha test. Okay. Let's get rid of this. So 0, 1, 2, 2, 3, 4, 5. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 is of course black again. So black is correct, but I think we need to retake some of the color here. So one is correct also. Yellow is really smooth, etc. 2 is correct. 3 is the gold and it's not goldish enough. But you know what, let's keep it. 4 is the green and the green is too much. 5 is pink and the pink is too much also. 6 is okay. 7 seems to be okay, I think. And it's more the 8, which is really white. Okay. So let's try to change 3 of them, and for that we would have to simply take the PSD file, which is Daruma diffuse.psd, and change this a little bit. So I only made some color here, so that's more simple to use. Let's make something a little bit like that, and maybe I could add a little bit of a tint into it just to be sure. Yeah, something a little bit gray, for example. Okay, so that was the first one. Oops la, where is my elements? Okay, so this is the white. The pink also is a little bit too prominent, so let's reduce it a little bit. Okay, the gold was not gold enough, so whoopla. This is the pink. The gold, where is it? The gold is here. Clearly the gold is not gold enough, so we need to change that. I think the vibrance would be good. let's add some level to that. It needs to be darker. Okay, more brownish in fact. A little bit of curve into it might be interesting. Okay, something more like that. So that's the gold. Okay, let's save this. Yellow is okay. Green was too much of those, so here is the green. Let's reduce a little bit the color. Violet was okay, black was okay, red was okay, so blue, pink. Okay, let's save each one of them. So I will automate things that I want. Let's automation, where is it? Construction de calque en fichier, c'est ça. I don't want that. We are on the good folder and I want a PNG24. And let's wait until it's finished. Oh my, it's working, but it's using an index for each one, so it don't rewrite my little guy. Oh, not a problem. Okay, my comp is correct, so here we are again. So I need to change the white, the pink, so the white, the pink, we've made also the gold and the green, so that was the 3 which we've made, and that is good because everything is correct. Okay, so this is the white, pink was here, gold was here, green was here, and this was the white, the pink, the green, the gold. I could resave them. Okay, and let's wait to Unity until it has fully imported everything. Okay, so now it's look like it's a little bit gray, so maybe it's better. They still have some let's reduce that, let's remove that, remove that, remove that. Okay, so where is our little guy? Maybe we can disable the sRGB value. No, we clearly need the sRGB. Okay, so what about the 5, 4, 2, okay, let's try that. Let's reactivate our little guy here. Oops, this is not the one I wanted, this was this one I wanted to, okay, and this I could get rid of this. We also need to remember that we can apply a little bit of color correction into it. So let's remove the diorama, let's reactivate our little guy, which is more and more Murakami guy. Okay, so now we have our little guy here. So let's reactivate our little Daruma and think about the way it behaves. Let's try to make some element here. So as you could see now, it's fully reflective, and Daruma it depends, but the gold one of course is more like fully reflective because it's kind of a reflective paint, but it's clearly more something with blur. So I think we would have a blur of the environment, and maybe not too much impact of the of this. We need to boost a little bit the color of the Daruma, so maybe 005 is enough to have something a little bit smooth. Maybe not enough, because as you could see, it seems to be a little bit too dark to me. So let's disable this one, and let's try basically to write directly here. Okay, so for me it's kind of correct. We have some things that has overexposed, but it's not a problem here. Okay, let's try now to try something with a little bit more scale. Because we have smaller elements, we could add more elements. Again, I'm not sure about having more elements, but okay. 0.5, 0.25. Let's go back with the global scale we had at first. So this one is clearly interesting. Okay, I think we need to reactivate on the compute shader the rotation. Okay, and maybe just maybe we can put some noise into it. Okay, so the curl might be interesting, for example, and maybe we could put the value of this curl, let's say the medium value of the curl in the data.y, because we didn't put any value in data.y. So let's try to say something like curl dot. So basically we want to have something like float based, so average curl, or we could make a random based on the curl, but I don't think it might be interesting. So let's create the average of the curl. So basically we take the curl, we will multiply by 0.5 by plus 0.5, just to have something more going from 0 to 1, so more easy to manipulate. Then this average curl will be simply equal to the average curl dot x plus y plus z divided by 3, and I could put that in data.y, of course, and now I can change this by using basically the data.y. So for example, in dot data dot y and see how the color are distributed or not. So let's try that. Invalid subscript y at kernel main. Where is it? Average, 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 curl, 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 and curl. Did I made a? I think I've made a mistake somewhere. Oh yeah, because I declared a float. So it's not that. I think if I put everything, yeah. Let's name this curl 01, and it would be a float 3, and then the other would be a simple float. So that's why we have a problem of components, and then this would be something like that. Now it could be working. Okay. And do we have something interesting or not? Clearly not. Clearly it's not interesting at all. So let's try new things. For example, yeah. Let's try with noised call as noise color. This would be a noise or a simplex noise, but a noise of the position, of course. Multiply by 2.60 by 2.75. My god. And this noise is basically between 0 and 1. We know that. Noise no matching parameter function. Of course we have this. No, this is the easing, but yeah, we have this noise flow 3. Did I use something elsewhere? Oh yeah, the comma here. That's the comma. And again, it didn't work. Why? Did I put everything in the proper value or not? In the data.y. Did I use the data.z and data.y? Data.y is here. So of course we have that. And then did we put the data is props.data, so it might be y. And in the data.y is not correct. It seems to be black. So why it's black? I didn't override this, so why? Try to put in the color to be sure that it's not a problem of binding. So in dot color dot a. Now it's white. Where did I made a mistake? look like we didn't bind everything correctly, so I'm not sure about that, but oh no, no, we use the proper one, so that's okay. And here we take the data, so o.data is equal to props.data, so it's not a problem here. So I could retrieve here in the data, so in.color might be equal to our little value which is put in our, which is doesn't has been put anywhere. And if I'm clearly trying to modify, to change things here, I'm clearly over my head, because I'm trying to change something in a compute shader which is clearly not the good one. So let's go back in the change here. Of course we have git, so we can override every mistake we've made on this one. Okay, let me go to the git to be sure that I will not change this one. So yeah, we were here in fact, and this is our little curl and our average on the curl, and we need to put this in the data.y, of course. And now we could use the atlas, so it would work. Not at all. So let me go back to try to change the compute shader. So which one I've changed? Vertex, surface, compute, controller, unity. It seems I haven't made any change in the 19, so it's okay. So I made a mistake somewhere. Where? So atlas is okay, so it's not here, but it's in the compute. I use curl 0, so curl, average curl. So the mistake was here. The value cannot be null. Let's say 0 for the moment, so it will be, we compile, invalid subscript white at kernel. Yeah, this was the mistake, of course, because as again it's a pure float value, so one component is not a vector. Okay, so let's try now, and let's hope we would have some kind of, so yeah, we have some kind of color now, but because we're using a curl based on that, it's clearly not really interesting, and the curl is moving really too fast. So let's call that noise call, okay, for the noise color system. It's a float, of course, and we would use the float, so we would use simply a noise, and we will call the oppose.xyz, which is not changing, or the position, in fact, simply the position, and not the curl, because the curl is really too fast. So let's try that. Again, I've made a mistake because I forgot to change the name of my value here. So now you could see the system, so that's okay. So we could change it a little bit, so let's say let's multiply by 4, for example. plus the time multiplied by 0.1 just to move a little bit, and I will need to go to again I'm not sure we would need to change that. Maybe we can simply try to define the color as a static one. Why the Daruma will change the color, I'm not sure. It might be strange to having some change in color, so we would use oppose instead. Because the change in color is not using some fade, is clearly... But we could use a little bit of randomness inside the nose, so let's use oppose the W, but it would be a static one, so it will not change. So yeah, now it's more interesting. Let's try to change it a little bit to change the pattern and something more like that. Yeah, it's more interesting now. And I said I would re-add the rotation, so let's re-add the rotation. Can we lap between two matrices? That might be a solution. HLSL matrix lap. Scalar, vector or matrix? Might be quite interesting to lap between the actual rotation and this, something like a lap between the rotation, this matrix, but with a random lap of 0.1, so we would have a little bit of movement. Let's try that. Oh my, I forgot if I lap between them, of course I would have some mistake inside. Okay, not a problem. No lap, only rotation. That's okay for me. Okay, I think this is good for me for tonight. We're ending a little bit earlier, which is quite interesting. So yeah, I wanted to play with Daruma, I wanted to play with more physics and something like more colliding system. So we have it. We have some collisions, so I think it's more interesting now. Another interesting would be adding some, use the time in order to change the behavior. So for example, if it's I don't know, maybe if it's follow, let me think, if it reaches a certain amount of time, it might go on the curl and then go back and try to remake a body, I don't know, changing the target or something like that. But we are viewing the system, so it's okay for me. I hope you like this little experiment. I kind of like this one. I haven't had a proper one with a full of colors, and the Daruma is really interesting and it's been a lot, so it has some really interesting message into it. So I hope you like it. I hope to see you tomorrow on another Convember, and until then I would say have a good night, goodbye, and take care, everyone. Bye.